Here is NUCIDA's weekly forecast of expected post activities in the realm of software quality on social media channels for week 7 of 2026. Our analysis is based on the social media post data from LinkedIn, YouTube, X, and other internet sources released last week, which revealed dynamic daily changes. I'll leverage the provided web results, which cover software quality trends for 2026, and combine them with logical extrapolation of ongoing conversations in the tech community. The ranking is based on the prominence of topics in recent publications, their relevance to current software quality challenges, and their engagement potential on the mentioned platforms. Each topic's ranking reflects its immediacy, impact, and discussion volume, with reasons for placement and a forecast for future trends included. So, what will be the top 10 hot topics this week? Buckle up and let's start the countdown. 10. Low-code and no-code testing platforms. Low-code and no-code testing platforms continue to spark interest in discussions about making quality assurance accessible to business analysts, citizen developers, and cross-functional teams who lack deep programming expertise. Recent LinkedIn threads, YouTube overviews, and blog articles from early 2026 emphasize how these platforms offer intuitive drag-and-drop interfaces that seamlessly connect with continuous integration and continuous delivery pipelines, drastically shorten onboarding periods for new team members, and enable faster creation of regression test suites for stable application areas. At the same time, critics in online forums point out persistent limitations in handling highly dynamic user interfaces or intricate business logic, which keeps the conversation lively and polarized. Organizations should carefully evaluate low-code and no-code tools only after they have already established robust, code-based automation frameworks for their most critical paths, and they should reserve these platforms primarily for repetitive, predictable regression scenarios while preserving complex, high-risk logic in more maintainable scripted solutions to avoid long-term technical debt. In the next 3 months, adoption of these platforms will accelerate noticeably as leading vendors introduce enhanced governance capabilities, version control integrations, and audit trails that effectively prevent uncontrolled test sprawl, shadow automation, and the accumulation of unmaintainable maintenance debt that has plagued earlier generations of low-code tooling. 9. API-first and contract-driven testing. API-first and contract-driven testing strategies receive steady attention in current conversations on X and specialized QA blogs, where practitioners stress the importance of validating service contracts and interface definitions at the earliest stages of microservices-based architectures to detect integration mismatches and breaking changes long before they propagate to front-end layers or production environments. Recent posts highlight how tools that enforce consumer-driven contracts or open API specifications as executable tests help teams achieve tighter collaboration between back-end developers and consumers while reducing the incidence of downstream surprises during deployment cycles. The topic gains extra momentum from discussions about its synergy with event-driven systems and asynchronous communication patterns that are increasingly common in modern cloud-native applications. Every organization should mandate contract testing as a non-negotiable requirement within every pull request workflow, treat API schemas and contracts as authoritative, living documentation that simultaneously guides implementation, drives automated verification, and serves as the single source of truth for inter-service expectations across distributed teams. Over the coming 3 months, contract testing coverage metrics will evolve into a standard, mandatory release gate in the majority of enterprise continuous integration and continuous delivery pipelines, with many teams expanding adoption to include backward compatibility checks and schema evolution governance as default practices. 8. Performance and reliability embedded in the core loop. Performance engineering and reliability practices now embed themselves deeply within everyday development and release processes, rather than remaining isolated pre-release checkpoints, according to multiple February 2026 analyses from Testlio, QWobble, and related industry voices that appear frequently in feeds and comment sections. Engineers increasingly treat baseline performance thresholds, degradation trends under realistic load, and chaos experiment outcomes as routine concerns that influence architectural choices, resource allocation decisions, and prioritization backlogs from the very beginning of feature development. This shift receives strong reinforcement from real-world outage postmortems shared online that link revenue loss, customer churn, and reputational damage directly to unaddressed performance regressions. Quality and engineering leaders should integrate load testing, reliability validation, and observability checks into regular architectural review forums and decision-making rituals, while explicitly linking these metrics to tangible business outcomes such as average revenue per user impact, cart abandonment rates during peak traffic, and service-level objective breaches that affect customer satisfaction scores. Expect continuous performance monitoring combined with automated reliability gates to solidify as default production practices within the next quarter, with forward-leaning organizations expanding these capabilities to include proactive synthetic monitoring and predictive alerting based on historical patterns. 7. Security and compliance embedded into daily quality assurance. Security testing and compliance validation integrate more tightly into routine quality assurance activities as regulatory pressures from frameworks like the EU AI Act and evolving data protection standards continue to intensify, with LinkedIn posts and blog roundups this week underscoring the necessity of turning quality outputs into traceable, audit-ready artifacts that demonstrate bias mitigation, explainability, and risk controls. Discussions frequently mention automated scans for vulnerabilities, privacy leaks, and fairness issues that run in every build, alongside requirements for documenting decision provenance in artificial intelligence-assisted processes. The topic attracts particular urgency in regulated sectors where non-compliance now carries substantial financial and operational penalties. Quality assurance teams must initiate close collaboration with legal, risk management, and compliance functions at the design stage to embed automated security and regulatory scans directly into build pipelines, pull request checks, and deployment workflows so that compliance becomes a continuous, frictionless byproduct of development rather than a burdensome last-minute hurdle. In the next 3 months, dedicated compliance-related test suites and automated evidence collection mechanisms will expand dramatically across industries as organizations race to prepare for stricter enforcement deadlines, mandatory reporting requirements, and third-party audits that increasingly scrutinize artificial intelligence system behaviors. 6. Shift-right observability-driven quality. Shift-right practices that leverage production telemetry, real user monitoring data, and live environment signals to continuously refine and prioritize test suites now dominate many February 2026 articles and social media threads focused on modern quality engineering. Contributors emphasize how observability platforms feed actual usage patterns, error budgets, and anomaly detections back into test creation and maintenance processes, enabling teams to retire obsolete scenarios, amplify coverage on high-impact paths, and respond to emerging failure modes far more quickly than traditional pre-production approaches alone allow. The approach gains credibility from shared case studies illustrating dramatic reductions in mean time to resolution for production incidents. Every quality-focused team should establish automated feedback loops that route real user signals, distributed tracing data, and production logs directly into test prioritization algorithms and backlog grooming sessions, using these insights to systematically retire low-value tests while aggressively expanding coverage around frequently exercised or failure-prone behaviors observed in the wild. Observability-driven feedback loops will tighten considerably in the next 3 months, enabling organizations to achieve faster post-release defect detection, more targeted regression suites, and a measurable shift toward proactive rather than reactive quality management across the board. 5. Quality engineering as the operating model. Quality engineering increasingly supplants traditional quality assurance as the prevailing operating model, with defect counts and test volume metrics giving way to holistic measures of release confidence, risk exposure, and system resilience, according to prominent sources such as QAble publications and cross-platform discussions that gained traction this week. Ownership of quality outcomes now extends explicitly to product managers, developers, platform engineers, and operations teams alike, transforming quality from a siloed function into a shared organizational responsibility supported by cross-functional rituals and unified key performance indicators. The evolution receives widespread endorsement as teams report better alignment and fewer handoff failures. Leaders across every discipline from product ownership through development to operations must actively own measurable quality outcomes, establish release confidence as a shared, visible key performance indicator tracked in real time, and embed collaborative quality practices into sprint planning, architecture decisions, and incident retrospectives to eliminate finger-pointing and accelerate collective accountability. Cross-functional quality engineering practices will solidify firmly as the default operating model by May 2026, with most mature organizations adopting unified dashboards that aggregate risk, confidence, and value signals from across the entire software delivery lifecycle. 4. Human-in-the-loop testing for artificial intelligence systems. Behavioral evaluation, bias detection, harm prevention, and ethical oversight of artificial intelligence outputs remain central to heated discussions in Tesla reports, LinkedIn commentary, and YouTube deep dives appearing throughout this week. Practitioners stress the ongoing need for diverse human reviewer pools, well-calibrated evaluation rubrics, structured escalation paths, and transparent adjudication processes to ensure that automated testing of large language models, generative systems, and decision agents captures nuanced failures that purely algorithmic checks frequently miss. The topic surges in relevance as more organizations deploy customer-facing artificial intelligence features that carry real reputational and legal exposure. Teams should implement rigorously calibrated rubrics, maintain intentionally diverse and representative reviewer communities, establish clear escalation protocols for ambiguous or high-severity cases, and integrate human judgment as a scalable complement to automation speed so that oversight keeps pace with deployment velocity without creating bottlenecks. Human-in-the-loop oversight mechanisms will become mandatory governance requirements in most regulated sectors and high-trust consumer applications within the next quarter, driven by emerging standards, audit expectations, and public scrutiny of artificial intelligence system behaviors. 3. Self-healing and artificial intelligence accelerated automation. Self-healing test automation that automatically adapts scripts to user interface modifications, locator changes, or minor application updates generates exceptionally strong engagement on X, appears in nearly every recent trend compilation, and fuels animated debates about maintenance burden reduction versus potential fragility masking. Early adopter anecdotes shared online report substantial cuts in test flakiness and upkeep effort, while skeptics caution against over-reliance on black box adaptations that obscure underlying application instability. The capability now ranks among the most discussed artificial intelligence accelerations in quality workflows. Adopt self-healing mechanisms selectively on mature, relatively stable application layers where change frequency is predictable, and always pair them with disciplined test design principles, explicit assertions, and periodic manual validation to ensure adaptations do not hide deeper architectural or implementation fragility that could surface under stress. Self-healing features will transition rapidly from optional premium add-ons to expected baseline capabilities in mainstream test automation frameworks by May 2026, with vendors competing aggressively on adaptation accuracy, transparency, and integration depth. 2. Risk intelligence replacing vanity metrics. The industry-wide pivot from vanity metrics such as test pass rates, total test counts, and coverage percentages toward genuine risk intelligence focused on defect escape rates, recurrence patterns, user impact heat maps, and predictive failure signals dominates high-visibility blogs, LinkedIn analyses, and X threads this week. Commentators praise the move for aligning quality investments directly with business protection priorities, while dashboards that once celebrated uniform green builds now face criticism for masking systemic weaknesses. The shift receives strong momentum from executive-level calls for outcome-oriented quality reporting. Quality leaders should retire outdated dashboards that prioritize superficial green status indicators and replace them with dynamic risk heat maps, probabilistic failure forecasts, and prioritized investment guidance that highlight the most likely sources of future customer-affecting defects and guide resource allocation accordingly. Risk intelligence platforms and associated visualization tools will become standard components in enterprise quality organizations over the next 3 months, with many teams integrating artificial intelligence-driven anomaly detection and predictive analytics to further refine risk scoring and decision support. 1. Agentic artificial intelligence and autonomous testing agents. Agentic artificial intelligence systems capable of independently planning, executing, debugging, and evaluating complete end-to-end test scenarios lead every major 2026 trend roundup, generate the highest engagement volumes on LinkedIn and X, headline numerous YouTube explainers, and provoke the most vigorous debate about trust, oversight, and job evolution in quality roles. Pioneering implementations already deliver reported reductions of 70% or more in manual verification effort on bounded workflows, with multi-agent orchestrations beginning to handle complex exploratory testing and regression optimization autonomously. The topic overshadows others due to its perceived potential to fundamentally redefine software quality practices. Organizations should initiate controlled pilots of agentic workflows on clearly scoped, low-risk user journeys or regression suites first. Enforce strict human review gates for any high-stakes validation or production promotion decisions. And invest heavily in explainability, audit logs, and rollback mechanisms until operational trust reaches enterprise-grade maturity. By May 2026, sophisticated multi-agent testing orchestrations will advance from experimental prototypes to active production usage in the most forward-leaning organizations, with broader mainstream adoption following as tooling matures, governance patterns stabilize, and demonstrated risk reductions accumulate. Looking ahead to 2027 and 2028, software quality assurance will mature into fully orchestrated ecosystems of multi-agent artificial intelligence systems that autonomously govern the complete software development lifecycle, from requirements, refinement through continuous validation, ethical alignment monitoring, environmental sustainability assessment, and direct business value quantification. Fully autonomous quality pipelines will become feasible, featuring self-organizing agent swarms that detect, prioritize, and proactively remediate issues across code, infrastructure, and runtime behavior before they ever manifest in production environments. Validation paradigms will expand dramatically to encompass physical artificial intelligence integrations, edge computing deployments, and real-world cyber-physical interactions that demand novel simulation, adversarial testing, and safety assurance techniques. Sustainability considerations will ascend to equal prominence alongside functional correctness, with standardized metrics capturing the carbon footprint of test execution cycles, model training runs, and inference operations becoming mandatory reporting elements. Organizations that successfully evolve quality into a continuously learning, self-healing, and value-aligned capability, rather than a periodic verification checkpoint, will secure decisive and lasting competitive advantages in an increasingly software-defined economy. Hopefully, this video gives you additional insights. What do you think about the hot topics this week? Write your views in the comments section below. In terms of further questions, feel free to write to us. We will analyze all important internet channels and release our analysis report every Monday. Follow or subscribe to this channel to stay up to date and know more than your competitors. Happy testing and see you next time.